Hello again, and here we go with page 4 of the District Assessment Review. Actually, before we do page 4, period 7 was kind enough to actually point out a mistake that I made on page 3. So go ahead and turn back to page 3 real quick. Okay, in the table for solid, liquid, and gas, I mistakenly put that the shape was definite for a liquid, but you need to change that and understand that it is indefinite. A liquid takes the shape of its container, and that's, you know, just think of water when you're thinking of that. If you pour water out, it's gonna take a different shape. Okay, so there's that mistake. And guys, if you find any mistakes, please let me know in class, and then that way I can clarify for somebody else. I'm human too. Okay, anyway, okay, page 4. Before we get into page 4, please open or find wherever you have your periodic table. Okay, I want to point out a few things for periodic table. Okay, so on the periodic table, you absolutely need to know the S, P, D, and F blocks, okay? So if you remember over the first two groups, that's the S block, okay? So we're gonna label that. This side over here that contains mostly the nonmetals, this is gonna be called the P block. Right in the middle with the transition metals is our D block. And then the one we usually don't talk about very much, but you need to know where it is. This one right down here is the F block, okay? Keep that periodic table out in front of you. You're gonna need it because this next part goes with electron configuration. Okay, so some things you need to know. Things you need to remember, I should say. First of all, some rules for electron configuration. The first rule says that electrons occupy the lowest available energy orbitals. That's what we refer to as Aufbau. Okay, that's our Aufbau principle or rule. Okay, so please remember that they always take the lowest energy configuration possible. The second rule here, I'm going to draw a little line there. The second rule is showing something that is incorrect. Notice that we have in the p orbital, there's actually two things incorrect here, okay? In the s orbital, notice that the 1s got filled with an up and a down arrow, but then the 2s is not complete. Well, that's a problem because we've already put more electrons into the p orbital, which violates Aufbau principle. So in other words, we shouldn't have any electrons in the p orbital until that s is filled. Okay, and again, this one, there's something else wrong with this picture as well, though. Notice that in the p orbital, remember we have 3 spaces for the p orbital? Well, our rule for Hund's rule says that we should give each of the spaces 1 electron before we go back to pair them down, okay? So remember we called that the up, 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 down, down, down rule, okay? The technical name for it, though, is Hund's rule. All right, this next one is called Pauli exclusion principle, and this one says that no 2 electrons have the same 4 quantum numbers, meaning if you're remembering the address analogy that we used, no 2 electrons will live in the exact same place. Okay, so the last one here, remember that orbitals will hold no more than 2 electrons, and if there are 2 electrons in one orbital, their spins must be opposite of each other. And we represent that with 1 up and 1 down arrow. Okay, so some other things to remember. When you're starting off your your electron configuration, you need to remember that atomic number is going to give us the number of electrons, and that's only true if the atom itself is neutral, because protons would have to equal electrons. You need to follow the order of the periodic table, and what does that mean? Well, what I mean by following the order of the periodic table is if you're reading it left to right, you start right at the top, at the 1s energy level, and you're going to go left to right. Once you finish there, you're going to go down to the next energy level, so 2. After you finish there, you're going all the way across. So no matter what, you're just going to follow the order of the periodic table. Okay, there is one more thing to point out on the periodic table is that after the 4s orbital, that's right here, then comes the 3D. Okay, so I've gotten a lot of questions as to why that's a 3D. Well, the easiest way to explain that is you need to remember that in the first energy level, there is only one type of orbital, and it's an s orbital. In the second energy level, there are two types of energy levels, s and p. And then in the third energy level, we have the introduction of the d orbital. Now, if this first d orbital isn't the third energy level, we wouldn't have anywhere to put that one, okay? So by default, this first d orbital has to belong to the third energy level. And to that effect, the fourth energy level is the first introduction of the f orbital. So if I were to ask you for down here, this one would actually be 4f. The way you saw it in that last video that you watched was, remember that the d is n minus 1, meaning the energy level minus 1, and the f orbital would be n minus 2. Okay, we'll come back to that. All right, so on your worksheet, in your review packet, again, follow the order of the periodic table. Remember that in p orbitals, you should always go up, 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 and then down, 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 referring to the arrows. And then this one, okay, noble gas notation, we didn't spend very much time on, so let's make sure that we can also understand that, okay? Noble gas notation is called the abbreviated notation. And what we're doing is using a noble gas from the periodic table and putting it in square brackets to represent the electrons in the core of that atom. Okay, so for example, we can do this for any atom, okay? For example, if I were to do, let's use calcium as our example. Well, the way I find which noble gas to use is that I'm gonna go all the way down the period and up one. When I move up one, I land on argon, okay? So for calcium, again, just using this as a quick example, calcium has all 18 argon electrons. Okay, so we would put AR into the brackets. And again, that just simply means that all of those 18 electrons are in calcium, but additionally, we have these two extra electrons. So the way to finish that notation would be AR and then 4s2, okay? So one more time, we're trying to do calcium here, okay? So we have to account for those s orbital electrons as well. Okay, the last thing to remember that you have over here is in your dot diagram. For dot diagrams, remember these only show the valence electrons and it should never have more than 8. That's important. If you find yourself trying to put like 20 electrons around something, you've done something wrong. Okay. All right, so going over to the examples. First thing you need to find is the atomic number for each of those elements. So hydrogen's 1. Looking on the periodic table, you should be doing this. Carbon is 6. Nitrogen is 7. Sodium, 11. Chlorine is 17, potassium is 19, and zinc is 30. Okay, so what are we going to do with those numbers? Remember, those numbers represent the number of electrons, and we have to fit those into the orbital notation. Okay, so 1 electron, remember we start at the lowest energy level first, and we're going to represent the first electron with an up arrow. Okay, then that's it. For 6 electrons, we're going to put 1 up, and since this is an s-type orbital, we can automatically pair it down. Okay, so we've used 2 electrons out of the 6, so then 3 and 4 will go in the 2s energy level, and now we have 2 extras that we need to put. Okay, so watch what I'm going to do in the p orbital. We're going to have 1 up, and you're going to be tempted to put the next one down, but that would be incorrect. The next one goes up in the next spot. Okay, for 7, 1, 2, 3, 4, 5, 6, and 7. Okay, for sodium, and you're welcome to pause this at any time, try it on your own, and then check your answers, which I highly recommend, okay? So for 11 electrons, 1, 2, 3, 4, 5, 6, 7, those are all up, and then 8, 9, 10, and then we have one more electron to put in the 3s orbital. Okay, for chlorine, 1, 2, 3, 4, 5, 6, 7, and then 8, 9, 10, and then 11, 12 go into the 3s. And now we have 5 more electrons that we have to put in. So we're going to put 1, 2, 3, and now we can pare them down 4 and 5. Okay, and that gives us 17 electrons. All right, now for potassium and zinc, there's something different going on. Notice that argon, is in the square brackets, okay? But again, that just simply means that it has all 18 of argon's electrons. And notice that we need one more to make it 19. That goes into the 4s. Okay, for zinc, again, we have Ar. How did we get Ar for those two? Remember how to find the noble gas to use? If I go to zinc on the periodic table and I follow it all the way over to the noble gases, move up 1. That's how we decided to use argon as our one in the brackets, okay? All right, so then for zinc, this is 18 electrons, so I need to keep going until I have 30, okay? So 18, 19, 20, and the d orbital is just like the p, where we're gonna put up arrows first. Then if we still have electrons, we're gonna pare them down. And it just so happens that zinc has a filled d orbital. Okay, now to transfer this into electron configuration, we're going to take the energy level and sublevel. We're going to write that out as 1s, and then count up how many electrons are in it and make that a superscript or an exponent. Okay, for the next one, carbon, 1s2, 2s2, 2p2. Right? We just got that by looking at this picture. And then for nitrogen, 1s2, 2s2, 2p3. And for sodium, 1s2, 2s2, 2p6, 3s1. Again, if you want to try these on your own, you should be pausing and then trying it and then checking your answer, okay? 1s2, 2s2, 2p6, 3s2, 3p6. Notice how these are starting to get longer and longer and longer? Well, that's where noble gas configuration is going to be very helpful. It's going to allow you to abbreviate it, okay? So then this next one, all I have to do is put Ar in the brackets and then anything that comes after it. See, it's nice, short, and simple and to the point, right? Okay, so for zinc also, Ar in brackets, and then 4s2, 3d10. That's much quicker. I think you like that. Okay, so then how do you translate this now into noble gas notation? Well, what I'm going to do is I'm going to find a filled energy level. Notice that the one energy level, the first energy level, is completely filled because that s orbital has both of its electrons, okay? This second energy level is not filled because p orbital doesn't have all of its, okay? So why I did that is because that's what's going into the noble gas notation. So 1s2 belongs to helium, okay? So then that's the noble gas in the brackets, He, and then anything that comes outside of it, 2s2, 2p2. Okay, for the next one, again, I see which one is actually filled. The one that's actually filled is the 1s. So that again is He. And then 2s2, 2p3. Okay, now this next one, we're going to put a bigger bracket because not only is the first energy filled, the second energy level is also filled. So I'm going to put my bracket around all of that. And when I look at the periodic table, that's going to be neon because it has the 10 electrons, okay? So Ne this time is in brackets, and we get 3s1, okay? Same thing on this next one. Oops, you know what? I made another mistake. Okay, right here in this electron configuration, our exponent on the P is not a 6, it's a 5. I didn't go back and count my arrows. Okay, so then the second energy level is filled. Again, that's neon. And oops, 3s2, 3p5. Okay, this one's just going to stay the same, so there's no need to rewrite that. Okay,